Okay. I
Recording has
think we'll get
started.
started. I think we have a forum.
Yeah, recording has started. So,
Perfect. Thanks, Srini. All right. So, if my name is Suresh Sankar, I'm from. We all from most of us are from Boston, Massachusetts. Thank you for joining the session on cloud computing. So I work as a technical account manager in AWS. I work. I've been in the industry for more than 25 years, but right now my job involves helping customers to mature and adopt the cloud uh, uh, technology in their companies. So I work with big customers. When I say it could be healthcare and life science industry, in the likes of all the big pharma companies you're aware of these days. So I work with them, work with their technical departments so that they can better use and adopt the cloud technologies. So that is my role in within AWS. I want this to be interactive at any point in time, and it's a casual session. If you feel like you have any questions that it's not clear, or if you want to ask them, please feel free to interrupt me. We have an hour, but I'm okay if you want to interrupt me during the thing. You can come off mic and then unmute yourself and then want to ask questions. That is fine. All right. So what are we going to talk today, right? So the first and foremost thing is we're going to talk about the definition of an application, right? Then we're going to talk about some basic concepts of what is an infrastructure it is, and then going into what is a data center, and then going into what is cloud and how AWS operates. And most importantly, we're also going to look at what we call like what are the AWS developer tools and some of the way to get education on AWS as a high school student. What are the benefits out there? So if possible, I'll try to do a demo as well. So that's something that's been up some infrastructure, how quickly you can build something. So that is the kind of the area I'm plan to cover today. So did anyone know so one of the things, right? Like what is an application, right? So we knew Instagram, we knew Fortnite, we know Netflix, the Snapchat, all these things. One of the common things is these technologies use AWS in some shape or form. They are hosted out of AWS. Netflix is public information. It is 100% all in AWS. Um, so have you ever thought about how these applications even work, right? So just to give us some primer on how these things work. So you have your mobile device, right? And then you either use your Wi-Fi at home or wireless if you're outside your home, or you may be using a physical internet connection. Basically, a wire is connected to the internet router, and then so basically the application that is the way you kind of connect to the internet, right? You need some network. So you have this mobile device can be a laptop, your iPad, your school computer, doesn't matter. Still has to go through some form of network connectivity. Either it could be any of these methods, and then they all go into connect to what we call a data center, where there are servers. Servers, think about your laptops, which are more powerful laptops, dedicated to one thing very well. This is a representation of a storage, this is a representation of a CPU, and they all hosted in a data center. Data center is basically, it could be let's say some companies own the data center. For example, Facebook builds their own data center. They don't use cloud. And they host this application code. Like any of the projects you do in Hackathon today is considered an application or a code base. So this application is hosted in a data center. Traditionally, this is the way companies are operating until like 10, 12 years ago. This is it's a good model because you have this data center isolated away from the company, and it's been working fine. But let's say you're Moderna. If you know Moderna or Pfizer, these days you should know them. And they will say, "Hey, I'm a drug discovery company. Why should I own data centers? That's not my core competence, right? I need to pay for power and all those things. I have to constantly babysit them, upgrade them, and all the maintenance. I don't want to do it, right? That's what companies started thinking 10 years ago, and that is replaced by something called AWS. So it's the same concept. Still, you need a Wi-Fi or a wireless connection or a physical internet connection, but you still talk to the cloud, right? Like you basically the data center is hosted and managed by AWS at a large scale. What it means is when these cloud companies buy the server storage, we can buy at uh, cheaper prices because we buy millions and millions and tons of storage, petabytes of storage, so we get economies of scale. The vendors who sell this, they kind of give us cheaper prices because we are able to scale at that level. So these applications could be Google Docs or Instagram or Fortnite or Snapchat or hosted in the cloud. That is a key difference. So from what it was there 10 years ago and what the cloud is doing right now. So you understand, right? This is the consumer devices, as I said, basic things. It could display information, pull information, or you can submit information. When you did the post registration, you probably submitted an application, and you're looking for a latest Instagram post or a story. You are pulling information. So that is what the consumer devices are. So there is some difference between what a personal computer and a server is. Uh, sorry. Um, so applications, you use your personal computer or laptop runs applications, right? And your user use them at home. But servers are a little bit different. These servers, as I said, lives in a data center. They need internet connectivity in some shape or form. And then using the internet, you can connect with applications or services that are running in this server. So just some fundamental concepts of what it is, what's the difference between a PC and a server. I'm going to stop for now. I know I gave probably a lot of information. Anyone has any questions before I go further? Everything's clear? No questions? Okay, it's fair. So what is infrastructure? So infrastructure are various components, right? So for example, it hosts information, right? Like for a website, it stores, it could be used to store information like a database. So that is storage or a server here. So there are different components. So something like, for example, we call it storage. It holds your data. Network that communicates between your device and a data center. We talked about the internet being the network layer. Compute, which is basically your CPU, or like say in your machines you're seeing Intel i7, and RAM is the memory, right? The CPU. So this combination of all these things is what a server infrastructure is. And that's what I talked about when you go to the cloud, companies are able to buy these at very, very cheap prices. Some terms we can get in cents. That is only possible because you're able to buy this at a very cheap price. So what is a data center, right? So a typical data center pretty much looks like this. This is like what it inside a warehouse. It's just almost like your warehouses you see if you've been to any of the big box stores like BJ's or Costco. It's pretty much the size of them. And you have these racks of we call them racks, and your computers or servers are racked in them. They have cooling because they need to have, they need to have high, always have to be maintained at temperature because these racks and these infrastructure generates a lot of heat. So they have this cooling devices and data centers. Some of them are like even a football field size, depending on the size of this. Just to give some context, within in the Massachusetts area, these are the locations of data centers that is there. Waltham, which is a suburban city outside Boston, has. Cambridge has a data center. These locations may have one or two data centers on their own. Maybe one floor is dedicated to a company and stuff like that. So these are some physical locations we have right now. This is even before the day of cloud. This is a picture of a typical data center, and this is what it looks like. These racks, we call it them, and they're hosted in like the rack shelves, like we call it. So basically, this is all infrastructure located in one place. They have dedicated cooling, and this is what a data center is. So just to give some analogy, right? So in the pandemic, we all started making pizza at home, right? So we kind of buy the dough, put the sauce in, bake it, and we make it. Or we can go to a pizza store and get it ourselves. So companies start this, right? Why are we maintaining and building all the secret sauces and do all these things? Sorry about that. Ourselves, right? Because this is a data center model and this is a cloud model. Because someone is building all the infrastructure for you, you just become a consumer of it. I just want to enjoy the pizza. I don't need to care about how it's made. All the ingredients I need to go and shop and maintain the store and wash the dishes. I don't want to deal all those things. I just want to consume it, right? So that's the difference. This is what the data center looks like. Making your own pizza, buying a pizza is what a cloud looks like. So what was happening before? Before 2008, we go to EMC for storage, IBM for some networking, maybe like server equipment, Cisco for networking. And this is the rack I talked about in the bigger picture. We kind of buy these racks. It'll be hosted in this, all the servers will be hosted here. We have to do all this plumbing work, all this DIY kits of assembling everything and buying all these things, right? This requires a lot of money and staff, right? For a company like Pfizer and Moderna, this is not the best use of their money, but they were doing it before 2008. Now, with AWS, you go to a console and, hey, I want a compute environment. I want to build a game. It's like a click of a button service which you get. I want to build a mobile application. We even have robotics applications. You can do the management governance like monitoring. You can manage costs. This is a very, very important thing that differentiates cloud. For example, in the traditional data center business, because we buy software or infrastructure from various vendors, it is difficult to find unit cost, right? So with the cloud, all the infrastructure is the same. I can pretty much like electricity bill. I can pretty much how much I'm spending, how much I can save, where I can reduce waste. That is not possible in the data center because we have heterogeneous infrastructure. That means I would buy something from Cisco, EMC. There are different vendors, so I can't. The prices are different. It's very difficult to find the unit cost. Unit cost is like what is 1 GB of RAM, 1 GB of storage really cost. That is very difficult to do or even impossible in some cases. So what is cloud, right? So think about this way. A single family home, some of us are privileged to live. I call it like data center, right? It's your space. You don't share with anything. You have a dedicated internet, dedicated Wi-Fi, water line, sewage line. That's a single family home. The cloud is like a multi-family apartment or condo, which looks like it. Many tenants live there and they share things. So what it means is we call each of these units as tenants, meaning that you will have an isolated area, which will be securely isolated, that you don't share. I mean, nobody can come in unless you want someone to come in, but it is in the shared thing. So that's why we are able to offer this economies of scale. But there is some shared responsibility when you're living in an apartment with respect to the data center. So when we really look at cloud, the term cloud is basically this cluster of the single family homes or the cluster of these data centers around the globe. So if you are building an application and you want everyone in the world to use it, you could pretty much host a copy of that anywhere in the world. Or there are other technologies to optimize them, which may or may not be a scope of this discussion. But so if I'm starting a company in India, for example, I don't need to go and build data centers all over the world if it has to be accessed by all over the, like if I'm starting an application like Netflix. Now cloud gives me the ability to start things at a click of a button, right? And if I don't want this infrastructure, a company goes south, I can pretty much rip it off and then say, hey, didn't work out. I'm going to shut down my infrastructure and delete all of them. That is not possible in the data center. So it helps in a new era for startups to open up, succeed. If the business model doesn't work, they can just shut it off easily. So it kind of helps the fail fast mechanism. And also you pay the infrastructure like electricity bill or a phone bill, right? You pay for every second. So you can really shut down. For example, I could shut down my non-production environments in the weekend when my developers are not working and save money, which is not possible. So it kind of helps in the cost spectrum, also helps in the innovation spectrum. So that is the power of cloud, I would say, that is given. So these are the regions. For example, in the U.S., in Northern Virginia, there are like this one is actually Ohio. So for the East, we have two regions. We call it cloud regions. In AWS terms, we call it EOS East 1 or EOS East 2. So we have the East. If you are, let's say you want an application to be hosted in the East Coast, you'll have one normally in Virginia, which is basically north of DC, and we have one in Ohio, right? So just to look at this, double click on this one. So we have Ohio and we have Northern Virginia. And people will be wondering, what is this GovCloud? So that means, let's say we have a separate regulations for federal and like CIA, Pentagon, all these things that have some regulatory requirements. So we have a dedicated cloud infrastructure for them. So like only CIA, NSA, Pentagon, and we have some of those not to be shared with everyone, but we have, I would say, federal clouds running in AWS. So most cloud providers have them. So there is one in Stockholm for Europe, and there is one in Hong Kong. And you'll see in China we don't have that. I'll talk about that in a second. But many countries will have regulations where the data cannot leave the country. So in those situations, we have to have this, separate clouds, because European Union's applications will only run off of this data center. So there was those things as well. But in China, we don't have any data centers. Basically, we don't have any regions. We own the intellectual property, and we build the data centers, but it's run by a third-party company that is registered in China, because China doesn't want any other company operating cloud in the premises. That's why we have AWS presence in the thing, but it is basically managed and maintained, but the intellectual property or the secret sauce is from AWS. It's the same thing for other cloud providers like Azure and Google as well. So China is kind of unique in that situation. Any other questions before I go further? As I said, you're giving prices and there's no dumb questions. Okay.
We have a question in the chat, actually.
Sure.
So the question is from Leo, and he says, is it cheaper for companies to buy the cloud service just from Amazon, or is it easier to buy than to make their own?
Anyway, it's a good question. So if they buy, as I talked earlier, like say you buy infrastructure, it has a cost, right? You buy storage and all these things. So, but when we buy infrastructure, we buy, like for example, let's say we want to buy storage. We are buying storage for all over the world, entire infrastructure. So when you buy any product at a large quantities, you get discount. So there is a difference between buying it in Walmart and buying in BJ's. Yes, the quantity is high, but also the per unit cost is cheaper. So in that case, it is very, very cheap, right? Just in the raw materials, right? The next thing is, when you manage a data center, you have to pay for the cooling. You have to pay for a data center tech, right? You have to employ them. Somebody has to maintain them, and the power can go out, and then things go south, right? And also you have to pay for electricity. For example, in the US, it is very expensive cost-wise. You could see people who are in Massachusetts on the East Coast, there's a reason why there is no, what I call data centers in Massachusetts or cloud regions in Massachusetts. In Massachusetts, electricity is very, very expensive. So all these costs, the resource cost, power cost, and based on the location, it is expensive in the long term for the companies. That's why cloud is cheaper. The ability to buy raw materials at a cheaper rate, and the regional locational cost really increase the overall cost for a company. That's the reason. I hope I answered the question. Let me know if you have other questions. All right. I'll go to the next slide. So what is AWS, right? So it's just what we call as there's a meaning behind the AWS web service concept. I'll get into in a minute. So it's one of the, I would say, because we probably AWS came to the market very early, maybe 10 years ago. They started with a simple service called S3, which is basically an object storage. A lot of companies, trust AWS to run this infrastructure. So especially the success story of Netflix. Netflix is probably the success story in the cloud, and they have, I would say, pushed the limits of the cloud. And anytime you're watching a movie, you are consuming AWS infrastructure. So as we talk about Fortnite, Snapchat, and all those big companies are running in AWS, so they trust AWS with their infrastructure. This 165 may be a low number. We have 165 services, so maybe it's 185. There's so many services that you can see: machine learning, GPU, high performance computing, website building, and all those things are available. So it is, again, these services are not available locally, but it's available all over the world. So AWS is just a flavor of cloud computing. So you probably know Fortnite. Fortnite is, I'm only talking about publicly public information. So for example, I can't talk about all of our customers. So if you look at the AWS website, you will see Fortnite. So if you're playing games, Fortnite, chances are it is running out of AWS. Netflix. So Netflix runs in AWS, but this is the open architecture of how Netflix runs. I'm going to go through a real high level. So before it comes to display devices, there is something happens behind the scenes and kind of tells you what are the different components that is used to get into your device. One thing to remember, because of cloud, I'm sure all of you have Lego boxes, right? You've done Legos when you're young or seen some things. So the cloud gives what we call like components. Like it gives you storage. It gives you a small function called Lambda, which will ability to run small micro level functions. All these things of Lego pieces, they're put together to build a Netflix solution or a content distribution service, right? This was not possible before, right? So in the past, you have to build all these things separately and then write code on top of it. So you don't need to do that. So in this picture, what it really happens is you have a movie file. Let's say, I don't know, Fast and Furious, right? It is pushed, those sources basically in the storage. And as the file is there, as the file is posted, when the file is available on demand, let's say you're looking for a file, the movie file is pushed into S3, and then it kind of triggers, hey, there's a file there because of Fast and Furious. And then there is this elemental media convert service, which converts the movie files are in a different compression to render into our devices. It has to do some conversion. So when the conversion is done, these are like monitoring and workflow services. So it is published to an S3. S3 is an endpoint, and then there is a CloudFront. I'll talk about that in a second. And then you're basically accessing that S3. Basically, if you really look behind the scenes, there is a URL that's embedded within your device, Apple TV, and that is the way you get it. So it is on demand. So you're not having all the files there. It is actually based on a request. We distribute the content to your device. So there's something to be called about CloudFront. I can explain that in a second what it is. It was there even before the advent of cloud, but this is called, I don't know if you heard the technology called Akamai. This is called cloud caching services. What it means is I am hosting an application of Netflix, right? So Netflix is here. And someone is watching the video in China. I cannot build another copy of the same infrastructure in China. What do I do is I kind of cache. So once, let's say I have what I call a caching infrastructure all over the world. So when a content is published, I cache them locally. meaning that I push that file everywhere. It could be as simple as an image file, right? So when a user hits Netflix, even though Netflix.com is based in Northern Virginia, it will come and check, hey, is this Fast Furious file in the Hong Kong area? The request is pushed back to the local infrastructure or local cache servers, and the content is served from Hong Kong. Otherwise, if I'm accessing, if a Hong Kong user come all the way to Virginia, it'll be very, very slow. So this is called content caching service. So that's what Netflix uses in that thing that we call that as CloudFriend. So many companies provide that. So that is the beauty of this. This technology was existing even before, as I said, before the advent of cloud. That's why if you go access CNN.com, you'll get the same speed, whether you access from India, Frankfurt, or from your home, because of the caching technology. Okay. So just to give that context, that's what this CloudFront is really doing, right? Before you go further, any questions? Any of the things I've shared, I know some of them could be complex, but I try to simplify them as much as possible. You may be wondering how it relates to hackathon, but I know the hackathon, you're doing a lot of programming, but this other spectrum of these things, once you're building these things, this is about the infrastructure side of tech, right? How do you use this infrastructure and how you use this, because you don't need to worry about it, right? Like if you have cloud, all you need to care about your idea and consume some services. So that is what I was trying to emphasize. If there's no questions, I will go to the next one. So the shopping cart experience, right? You can say, I want a Linux VM. I can go and select this, right? These are, we call it AMIs, or Amazon Machine Images. So this is not only has this hardware, but it has the Linux of SSD volume, and it tells you like what's the NIC and all those things. Comes with 5 years support. You can select it. You want an Intel chip, an ARM chip, you just select that. And then you tell them what kind of CPU you need, what kind of memory you need, and what kind of performance you need. You just select them as well. And then it asks you a confirmation. You click the launch button. It probably takes 3 minutes to spin up this. This was not possible even like 8 years ago. It was even take 2 months because there is so many other things that has to happen in the data center thing. This kind of shopping experience was not available, this automation. The one more important thing I forgot to mention is the power of cloud is why it's called web services. Remember, I was talking about the web service. So everything I did now can be automated by calling an API. What it means is we call it infrastructure as code. Everything you do in the console, click, 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 it can be automated, and you can write programmatically. So programmatically, I can say, spin up a Amazon Linux machine without going and touching anything. Think about Netflix, right? Do you think Netflix is going to click, click, click whenever you want an infrastructure? They're not doing it. People don't even go to the console. The most mature customers don't even go to the console, and everything is done programmatically by calling the APIs to build infrastructure. So we call it software-defined networks, or we call it infrastructure as code. It follows the same software development principles as we do it in applications. So that is the reason we call it web services. It's not the infrastructure we provide, but we provide APIs so that you can control these infrastructure provisioning through software. So that is the beauty, because most companies, let's say you're running a stock operation, you can't go and click, click, it's too late. Any questions before I go further? Okay. All right. So there are a lot of developer tools that may be relevant to hackathon, right? Cloud9 is an IDE, like a software development IDE for running and debugging code, any language. We have a lot of code deployment, like code build, code commit, code pipeline. So you can use all those things as well. So this could be relevant to you if you have AWS credits. So I'll just touch upon some of the things like code artifact. So for example, if you have public repositories, So it helps you to manage like a cost-effective artifact management. You can manage manage access policies for a domain like a repository, and kind of gives that inbuilt service. For example, you don't need to maintain that Git infrastructure or any kind of repository infrastructure. All you need to kind of interact is to push code and pull code, and we can apply policies. It's like we call it a managed service, that you don't need to manage the service you need to consume. You just pay by how many repositories you have, right? The other one is code build, and it provides environments for all kind of languages, Python, Node.js. You can also build your own build environments as well. So code build support, and also code commit, right? So there's also AWS Code Commit. I mean, these are like competing technologies for Git and other like even Jenkins. But again, we have our own service that you don't need to maintain a Jenkins or artifacts and all those things, Git and all those things. We're just providing as a service for you. Just to give a high level on that. Any other questions, anyone? Looks like I explained it clearly, or it's very difficult to understand. All right. The next thing is, how can you learn AWS? Okay, so there is a program called AWS Educate. If you can register that with your school or primarily your school email address, you can't use your personal account, and it gives you learning paths, and you can get based on your age, you can have a lot of certifications and learning things you can offer at no cost. So this is a great way to learn cloud. I would say, I'm employee of AWS. I'll talk about AWS. In one way, it is like if you learn AWS, the chances are you will understand, you will be valuable. You can transfer the skills to any cloud technology. For example, it's just doing the Sony TV and Samsung TV. It is called differently, but different terms and used, but it's all the same. So, that is a way to learn AWS. I mean, you can look at that website, AWS Educate. So that is all I had, but do you have any other questions about cloud? Is it, because the term cloud can be very overloaded. Any questions, anyone?
I think there's another question in the chat box. So, it says, does your school have to be registered for AWS, or does any school email work?
Any school email would work. Your school doesn't need to register, but if you have issues, you can post any questions in the organizers. We'll be able to answer. I should be able to answer that, but I don't think school is required. School doesn't need to register.
The one thing with school emails is sometimes they don't allow out external emails.
Oh yeah.
Students receiving external emails, so that can potentially be a problem. I have faced that before when trying to apply for certain things, so the mileage may vary.
Yeah, that is true. Yeah.
I remember I tried, and it was like yours isn't a school account, or your school isn't registered as an institution or something. So I feel like you have to use like a .edu email, but I guess for everyone your mileage may vary.
Yeah. I mean, there's some hiccups. I probably should have like some more details. I'll probably get it next week when I go back to work. So there is some, I would say, challenges there, because I think they assume everyone has an edu address, not org. So if people are interested, and post a Slack note to me, I can get you some other details directly emailed to you. Okay, so I just wanted to show this one. I'm going to probably show you how quickly we can build infrastructure. This is something I built in probably a minute or so. we got this infrastructure built. So let's talk about Beanstalk. Beanstalk is basically, let's say you want to build a web application, and then it could be any middleware, right? It could be .NET, PHP, Node.js, Python. You can create that environment to deploy web applications. So traditionally, what people do, they build a EC2, they install an IIS server, they install the libraries, and takes a lot of time, right? All you need to worry about the web application you're trying to build. So it's kind of a very, very simple process. You just give a name, app1, and you choose what platform you want to use. For ease of the discussion, I'm going to say I want to build a .NET, or I can say I want to do a Python. So it tells you what Python runtime it's going to install and what version. You don't need to do it. It's just saying for this application, develop a Python application. It's building all the middleware, and I'm just going to create an application, right? It's a sample application, but it's doing everything, as you can see. Hey, hope everyone can see my screen, right? Just.
Yep, you're good.
Yeah, okay. So yeah, it's going to create it's going to create the infrastructure, the binaries, and it is going to give you access to that. You'll not have access to the disk per se, but you will have access to deploy the code and only. So as a developer, you don't need to worry about what the infrastructure it's running on and how it is managed and all this stuff. Monitoring is taken care of, patching is taken care of. All you need to think about what's a great idea and how you want to enhance this website. For example, they created security, the network security is built, the environment health, can be monitored. So it's allocating storage for environment data. So within few minutes, you will have the environment, right? So this was not possible before, right? A few minutes, I'm building a test environment. And you don't need to care where it runs. You just need to chase. I just said it's in Northern Virginia. That's all I say, and I give a name. So this is what I call like the speed or the power of cloud, right? How quickly you can build infrastructure, so that all you need as a developer need to just worry about your development and deployment to production, right? So that is an example of how quickly you can build infrastructure in the cloud, right? Because traditionally it will take not this much time. I worked in EMC as a infrastructure lead. To build complex environments for EMC.com, it will take months. I'm not talking about a single application. I'm talking about a very, very complex application. In the cloud, it will probably take a few days as opposed to few months. So also the time to market is extremely fast because of the automation that cloud companies can provide. So as this environment is getting built in a few minutes, I will open up for any other questions. I've kind of come to the end of my presentation. I think hopefully you have some idea of what cloud is and what it's not. And maybe you will be able to, use them in your future projects.
Any questions for Suresh? Keep in mind the prize thing is still there, so if you're engaged, then you are in for a prize. Leo has a question. Are there any rival services to AWS? If so, what makes AWS better in comparison?
Good question. Though I'm not going to be, I will be biased by saying AWS is the best. But let me tell you the facts, right? There is obviously Microsoft has Azure Cloud. We also have Google. Google has GCP, Google Cloud Platform, called GCP. So the only advantage I would say is so there is a difference between iPhone and Motorola, Nokia smartphones. It is not that one is better than the other, because AWS came into the space, I would say, 10 years ago. We have a lot of maturity in our product and also experience. Like any other product, as you it has bugs, feature gaps, and all this stuff. So our early first in market advantage has been with AWS because we have what I call been in this space for a very long time. And we've been working with a lot of customers because of that, like because of the spread and the reach of AWS and popularity of AWS. So we have a more mature product because we have addressed all the bugs and our own internal maturity issues because we've been in the space for a very, very long time. So Azure came in like 5 years later. GCP came 2 years before Azure, after Azure was even a thing. So, and our cloud maturity is extremely high because like many other, like if you look at Google and Azure, they have many other, like as a company, Microsoft has many other products. We come to AWS, we have only one product that is called cloud. We don't have any other interest, right? We don't have any on-prem. If you look at Azure and they have their own on-prem business. So we have a good focus. And I would say my personal opinion, I mean, it's nothing, this is not a message opinion. Personal opinion is basically our first mover advantage gives us more expertise and maturity on our product line. I hope I answered the question. Okay, so as you can see, this environment is almost up. It's still pending finishing its last steps. So this is kind of a demonstration of how quickly you can build infrastructure. So with that, I'll conclude my screen sharing. I'll just open up for questions. Any other questions, anyone?
I have a question. So, how has machine learning or artificial intelligence been implemented with the AWS recently? Like, and how exactly does that work for the new participants here? Yes.
When you say you're talking about services or how we use AI ML internally at AWS?
I guess a mix of both. Yeah.
Okay, so we have a lot of service in AML. I've never considered myself an AML expert, but I'll give you how I call it how we use our own services, right? Like for example, when it comes to we have to eat our own dog food, right? We should not use machine learning from our competitors. So we use our own machine learning products. So for example, one of the things I will tell is for cost, right? For cost up, because now there is a big problem. Companies buy a lot of infrastructure, but they don't use optimized. So we have machine learning enabled optimizer, like we shall tell you what our view that it's all the infrastructure is t-shirt size, right? Small, medium, large. So we just use this feature called compute optimizer. We enable it, and then after a day, it runs a lot of machine learning and AI algorithms and comes with the recommendation the day after and says, hey, instead of using medium, can you use two smalls? Instead of using extra large, can you use two larges? Hey, this computer does not use storage as much. Can you go to a lower size? So we use machine learning in predicting based on the patterns of data that infrastructure uses and give recommendations. And we also use in cost anomalies, right? Like so some outliers we see in spend, we kind of alert the customers. So machine learning is models are employed to even save cost. And we obviously use our own, SageMaker is a popular service. We obviously use our own product, right? So machine learning is even used to better use of infrastructure, because this entire topic is about infrastructure, but we leverage machine learning in these examples to kind of optimize our own thing. All right, I know it's 6:47. If there's no other questions, I'll adjourn, but I hope this was a useful session for you guys.
Any final questions for Suresh?
I have a question. How good is like the AWS security, and like how are the customers like safe from hackers and stuff?
That's a good question. For example, we have, first of all, we have to secure our own infrastructure, right? So there is two parts to it. So even going before security, there's something called Shad responsibility model. And you can look it up and I can bring it up in a second. So what it means is, let's say we provide a server or network. We own the security for it, okay? So let's say you have this, let me bring this up. This is, I'm going to share this, reshare the screen. It's a question. So hopefully you can see this. Okay. Can everyone see this? Srini, can everyone see the screen which I'm sharing?
Yeah, we can see it.
Okay. So this is what it is, right? So AWS is responsible for the security of the cloud when it comes to the storage, compute, database, networking, and the regions and all those stuff. But anything above, the customer is responsible. For example, let's say it's an S3 bucket. Simply thing, right? You put some images on it. If you open it to the entire world, meaning there's no security policies, if somebody hacks, the customer is responsible. But if the customer put everything in his control, all the security policies and stuff, and then they get hacked, then it becomes AWS responsibility. So that is where I said everything is a shared responsibility model. The data, for example, you put some data, the data gets corrupted because of a hardware failure, then it's our responsibility. But you put incorrect data and then you send a report to the government, and that is your problem. So we provide a container, but if you misuse the container, it's like a car, right? Like if you drive if you can buy Tesla, but if you crash the car, and you can't blame Tesla, right? Because you're driving the vehicle yourself. So anything underneath the infrastructure, AWS is responsible. Above that, the customer is responsible. So that's what we call a shared responsibility model. So the security, to answer your question in a shorter way, it depends, and there is a boundary of who owns what responsibilities are with whom. So this is not even just for AWS, this is the same for most cloud providers. Hope that helps. Any other questions? Okay, let's stop presenting again. All right, Srini, I think we're coming to the conclusion.